So I hope all of you can see my screen. So in the previous class, we were doing the plastic analysis concept, okay, and in that plastic analysis concept, we were supposed to do the bending of a rectangular beam, okay. So let me draw a figure for you so that uh, okay, or let's start. So now if we have a rectangular beam, okay, let us say the beam is like this. I'm showing the cross section, okay. Let us say this is the beam, this one is B, that is the breadth, and this one is the depth of the beam, okay. So for this bending of this rectangular beam, we have some equations, okay, and those equations are called, or those equations are, so you may write the equations for elastic bending are the equations for elastic bending are, what are the equations? The phi equals to 1 by r, which is equals to minus epsilon by y, which is equals to sigma in by, this is minus e ey, okay. Now, and one more equation is there, that is m equals to e into I into this phi, okay, and my equals to sigma y into s, okay. Now you may ask, sir, what is this everything? So this is the moment, this is the yielding moment, okay. Now what is this r? So r equals to the radius of curvature. Just remember these equations, that's it, okay. And what is phi? Phi is the curvature. Next, what is this s? This s is the section modulus, okay. Now what is the sigma y? What is the sigma y? So sigma y is the stress at yield level, okay. Okay, so now let us consider this rectangular beam over here, okay. So here in rectangular beam we have three different stress levels, okay. For this rectangular beam we have the stress and strain levels, so that is, so for this rectangular beam I will draw here, there are different stages, okay. So if we plot the stress and strain in this axis, then we may say that it varies like this, okay. Then from here it is constant, and then it varies like this. Now we have some levels, these are some of the levels. This is level 1, this is level 2, this is level 3, and this is level 4. Okay, so, or I may show it equally, then I can show it here, and this will be my level 4. Okay, now so this is stage 1, this is stage 2, this is stage 3, this is stage 4. Okay, now at what actually happens, okay, what actually happens in this one. Okay, so this is the one for this, we call it as the plastic bending of rectangular beams. These are the different stages. Okay, now what happens in stage 1? So I'm writing it here. Stage 1. So here I'm writing, all of you please write down this one. Okay, so at stage 1, the strain at extreme fibers are yield strains. Okay, and this one. Okay, so till this point, so or at stage 1 we have the yield strain values. Okay, so that therefore okay, or before that I will write one more line, the stress distribution, sorry, the stress distribution is linear for this stage. Okay, so next one. So here, so at this stage, or what I will say, which color should I choose? Let me choose yellow. So when you increase the force, okay, so the stress strain relation, it varies, it becomes linear, and it reaches this point. Okay, so after this point, if we further increase the moment, okay, now let us talk about the stage 2 here. Okay, so I'm writing stage 2. Okay, so at stage 2, so I may write at stage 2, the yield strengths are up to a depth of d by 4 from the top and bottom. Okay, and here the stress distribution is partially elastic. All of you have to remember these stages: partially elastic, comma, elastic. Okay, now please focus on this first sentence. So at stage 2, the yield strains are up to a depth of d by 4 from the top and bottom. So this means that, let us say, for stage 2, for this stage 2, okay, this is the cross section of the beam we are considering. Okay, this is B, this is D. Okay, so the strain levels, the level of strains will be this one, this much level. Okay, so this is D by 4 from top, and the strains will be again D by 4 from the bottom. Okay, so in the stage 3, so now let us talk about the stage 3. Stage 3. So stage 3, if you can see, stage 3 also similar to this. Okay, so I can write here the stage 3 is similar. Stage 3 is similar to that of, it is not same. Okay, stage 2. Okay, but the strain levels, but the strain or the but the strains are up to a depth of it is 3 by depth of 3 by 8 from the top and bottom fibers. Okay, so here the strain values will be like this. This the same beam, this is the same beam. So at stage 3 we will have the strain values like this. So it will be, this will be the, these will be the values of strains. So it will be 3 by, this is B 3 by 80. Okay. Now let's talk about, okay, see, from stage 4 what happens? The strains are for full depth. Okay, so you may write like this. So at stage 4, or I'll write it as stage 4 first. at stage 4, the full depth of beam has strains more than the yield strain, that is epsilon y. Okay, full stop. Next is however the strains at top and bottom fibers should not be more than the epsilon st. Now what is epsilon st? It is the strain at start of strain hardening. Okay, so that's why that one, this is again B, this is D, so we may call this entire region is covered with strain, and it is D by 2, and this is D by 2. Okay, so let's summarize this whole stage. Okay, so let us summarize this whole stage. So first one is the beam. This is the beam. Okay, this is B, this is D. Okay, so at stage 1, literally nothing is there. This is stage 1. Okay, till PA epsilon this yield strain, nothing is there. Okay, at stage 2 we have, so it is D by 4, and this is a stage 2. At stage 3 again we have, what is the strain levels at stage 3? Who can tell? Harshvardhan, what is the strain level at stage 3? 3D by
3 by 8.
3D by
3 by
8.
8.
Okay, this is at stage 3. Okay, and at stage 4 we have, this is B, this is D. So here, sorry, simple, right? D by 2, D by 2. Okay, this is the strain levels. Okay, now if we talk about the strain distribution, at stage 1 the strain distribution. So I am writing this one as strain distribution. Strain distribution. Okay, so how the strain is distributed, please check here. So strain will be distributed like this for stage 1. Okay, for stage 2 it will be similar. Okay, but here it will be half of this depth, so it is d by 2. It is also d by 2, so the total depth is d by 4. Okay, that is, so here at this point we will have the epsilon y. Okay, next one for stage 3 it will be somewhat more. Okay, and for this one the strain value will be way higher. Okay, or sorry, this distribution will not be like this, it will be just a minute. So this drawing, this distribution the thing is very tough for me here. Okay, so similarly you can draw for the stress part also. Okay, so the stress distribution will be similar to this one. Sorry, here I should write stress distribution. So just like this, for stage 1 the stress distribution will be similar, and for this one the stress distribution will be for till this point it will be somewhat constant. This is one single line. Okay, this is sigma y. This is also sigma y, same value. Okay, so at this stage the stress will be and for this one these will be the stress distribution. Okay, now next thing is the curvature relation. Okay, so for this curvature relation, okay, so here we may write the curvature at any stage. At any stage means at any stage for this stage 1 to stage 4, at any stage can be obtained from that particular stress distribution. Okay, now, so for stage 2, okay, that is called the elastoplastic range. Okay, so for elastoplastic stage 2, the maximum elastic strain is epsilon equals to sigma y by E, and this tan phi, this will be equals to phi, that will be epsilon by y epsilon. Sorry, not y epsilon, it is y0. So it is epsilon by y0. Now what is y0? So y0 is, what is y0? The distance from NA. NA stands for, what is NA? Neutral axis. Distance from neutral axis to the extreme elastic fibers. This one. So all these values. Okay. All these values. Okay. This d by 8, d by 4, d by 2 and all. Okay. So all those values will be the y0. Okay. From the neutral axis to the that one. Now let's talk about the moment. Okay, one thing I missed here. Okay, so if we put everything, so for this phi equals to E by epsilon by y0. If we put all the values, that is, in place of epsilon, if we put this one, then we may say that phi equals to, so instead of epsilon it will be sigma y by E into y0. Okay, now let's talk about the moment. Okay, so here I may write moment. Okay, so all these we are considering with respect to the plastic bending of a rectangular beam. Okay, so here I can write the moment at any stage. The moment at any stage can be obtained can be obtained by integrating in the stress areas. Okay, now let us consider, for example, let us consider the stage 2. Okay, so just an example, let us consider let us consider stage 2. Okay, so at stage 2 the stress distribution is, how is the stress distribution? The stress distribution is like this. This is the neutral axis. Okay, this is sigma y. This will be equals to, what is the, this is the sum of what? This is the sum of this one, this portion, and this portion. Okay, so this will be, and it will be like this till here it will be. So this one is sigma y plus again this whole one whole structure. This whole structure is this one. I'll show it to you. And minus something is there. Now what is that minus? That minus is again till this one. Okay, so this entire thing is, we call it as the stress distribution of partially plastic section, that is stage 2. Okay, it is, or am I right here? Stage 2. Okay, now for this section if I consider the moment, so that will be the equation of moment will be m equals to sigma y into s0 plus sigma y into z plus minus again minus sigma y into z0. Okay, now what is this s0? So s0 is section modulus. We have two things, that is s0, z and z0. Okay. So s0 is the section modulus of the elastic interior portion. Now only this z, okay, this z is plastic modulus. Okay, now z0, this z0 is plastic modulus of interior portion, which is actually elastic. Okay, so if I take, so for this equation I may write it like this. Write it like this, that m equals to sigma y. If I take sigma y common, it will be s0 plus zp. Now what is zp? Zp is, or where zp equals to z minus z0. Okay, therefore now let us take the any rectangular section. Okay, if this is b, this is d. So how to find out this s0, this section modulus of, sorry, this s0, how or what will be the value of s0 for rectangular section? So please write down here. So for rectangular section, s0 equals to b into 2y0 whole square divided by 6. That becomes 2 by 3 into b into y0. What is y0? I told in the starting. What is y0? You can say what is y0? It is the depth of, or the distance from the neutral
Distance
axis
from neutral axis.
to the extreme fibers, right? Okay. So this becomes 2 by 3 into z0. Okay, this whole thing b into y0 is 2 by 3 into z0. Okay. Now, sorry, z0 equals to 2b into y0 into y by 2. So that becomes b into y0 square. Okay, and z equals to, we already know it is bd square by 4. So the moment m, what is m? So m equals to sigma y into s0 minus zp. Okay, so it is sigma y into s0 minus, sorry, s0 plus z minus z0. Okay, so this implies if we put all the values, it is sigma y into, what is the value of s0? It is 2 by 3 z0. So 2 by 3 z0 plus z minus z0. If we take that, this final value becomes, this implies m, the moment at any section for a rectangular, the moment at any rectangular section will be sigma y into z minus z0 by 3. Okay, this is the moment value. Now, what about maximum moment? Okay, so the maximum moment occurs, the maximum moment occurs when will be the maximum moment? Okay, how this maximum moment will be maximum? If this value, if z0 value, because we are deducting z0 from the section modulus, okay, if this value becomes 0, okay, when, then moment will be sigma y into z. Okay, when, I may write, when z0, sorry, when z0, this is creating a lot of trouble, when z0 is 0. Okay, so this stage is called, so therefore m equals to sigma y into z. This is also called as mp. Okay, and this mp at that stage is called the plastic moment. Okay, so this is the for the plastic moment. So in the next class, that is today I will take the class from 3 to, your lab starts from 2 to 3, 3 to 4, and 4 to 5. So I will take another class from 3 to 4. Okay, probably Joseph Jaiswal sir, he will take 2 to 3. I will take 3 to 4. Okay, so I'll take the attendance for that class at that moment. Okay. Okay, guys. Thank you. You may join for the next class.
Okay, sir. Thank you, sir.